Imagine a planet where the limits of habitability are pushed to extraordinary extremes. A world that outperforms even Earth's suitability for life. NASA's groundbreaking finding reveals a planet that defies our expectations, offering a tantalizing insight into the possibility of life forms beyond our wildest dreams. Prepare to embark on an adventure to a realm where the possibilities of existence are redefined when we discover a planet even better suited to life than our own. NASA has recently discovered a rare Earth-sized planet in a habitable zone. Planets are similar to Earth appear to be a decent place to start when looking for life outside of our solar system. We can now add astronomical objects TWAS 700e to that list of promising candidates. TWAS 700e has been proven to be in the habitable zone of its parent star, TWAS 700. That is the region of space where considerable amounts of water on its surface are at a temperature suitable for liquid formation. These planets are deemed just right for life as we know it because they are too warm for a coating of ice while remaining cool enough for vapor to condense. TWAS 700e was discovered and named by NASA's Transiting Exoplanet Survey Satellite, or TESS. TWAS stands for Test Object of Interest. It is the second planet in this system's habitable zone, following TWAS 700d, which was discovered in 2020. As a result, the TWAS 700 system is an intriguing option for further investigation. Planet E is around 10% smaller than Planet D. Therefore, the system also demonstrates how additional TESS observations aid in the discovery of smaller and smaller worlds. TWAS 700 is a tiny, cold star, known as an M dwarf star, situated in the Dorado constellation around 100 light-years away from us. These stars are not as massive or as hot as our Sun. Therefore, planets must be closer to them for temperatures to rise above freezing. TWAS 700e is thought to be 95% the size of Earth and mostly stony. It is located in the optimistic habitable zone, which means that water may have existed at some point in the past. TWAS 700d lies in the conservative habitable zone, which scientists believe will have liquid water for the majority of a planet's surface. These exoplanets, planets outside our solar system, are visible to telescopes as frequent blips in the light of their parent stars when they pass in front of them, a phenomenon known as a transit. Larger planets have more surface area to hide the star's light, making them easier to spot than small, rocky worlds, making Earth-like finds like this one a rare gift. TWAS 700e takes 28 days to complete a single orbit, but TWAS 700d, which is slightly further away, takes 37 days. Because TWAS 700e is smaller than TWAS 700d, more data was required to prove if the silhouette truly represented a new planet. TESS is monitoring roughly 100 million stars, so any way we can narrow down the hunt for life will be beneficial. Finding exoplanets in their respective habitable zones is one of the greatest methods we have. Both TWAS 700e and TWAS 700d are assumed to be tidally locked, which means that one side of the planet is always facing its star, much how the moon is always visible from Earth. To be sure, having one side of a planet constantly roasting in the sun reduces the likelihood of sophisticated life getting off to a good start. The 10 most Earth-like exoplanets identified so far provide insight into the diversity and possible habitability of distant worlds. Each exoplanet has distinct features that contribute to its Earth-like classification. Gliese 667cc. Gliese 667cc is around 4.5 times the mass of Earth and is located 22 light-years away. It is in the habitable zone and orbits a red dwarf star. However, because of its proximity to the star, it is vulnerable to possibly strong flares. Kepler 22b. Located 600 years away, Kepler 22b was the first exoplanet discovered within the habitable zone of its star by the Kepler telescope. It is approximately 2.4 times the size of Earth, but its composition is unknown. Kepler 69c. Kepler 69c is approximately 2,700 light-years away and approximately 70% larger than Earth. Its orbit is similar to that of Venus in our solar system, and it receives enough energy from its host star to support possibly livable circumstances. Kepler 62f. This exoplanet is about 1,200 light-years away and is roughly 40% larger than Earth. It orbits a colder star than our Sun, but is still in the habitable zone, making it a strong candidate for rocky planets with liquid seas. Kepler 186f. located around 500 light-years away, Kepler-186f is just slightly larger than Earth, by no more than 10%. While it receives less energy from its red dwarf star, it is still within the habitable zone. Kepler-442b. Kepler-442b is 1,194 light-years away and 33% larger than Earth. It completes its orbit around its star every 112 days and, due to the amount of radiation it gets, has the ability to support a huge biosphere. Kepler-452b. Kepler-452b circles a star around 1,400 light-years away that is similar in size to our Sun. It is almost 60% larger than Earth and lies within the habitable zone, making it an appealing possibility for further research. Kepler-1649c. Initially mistaken, Kepler-1649c was eventually revealed to be similar in size to Earth and to be located within the habitable zone of its star. It is 300 light-years away and receives roughly 75% of the sunlight that Earth does. Proxima Centauri b, the closest known exoplanet to Earth, is only 4 light-years distant and has a mass 1.27 times that of Earth. Although it is in the habitable zone, it is subjected to significant quantities of UV radiation due to its proximity to its star. TRAPPIST-1e. TRAPPIST-1e, one of the TRAPPIST-1 system's 7 Earth-sized planets, is thought to be one of the most plausible prospects for harboring life. Its proximity to the habitable zone and the possibility of liquid water make it an appealing target for future research. The Earth Similarity Index, ESI, is a scientific statistic used to determine how similar a planet or moon is to Earth. It considers factors such as temperature, air pressure, and habitability. The index has a scale of 0.0 to 1, with 0.8 to 1 signifying a high similarity to Earth. T-Garden b. Like the Moon, T-Garden b is tidally locked to its star, which means that one side is always facing the star. This can cause dramatic temperature fluctuations between the planet's sunlit and dark sides. T-Garden b's thin atmosphere could play an important role in spreading heat and cold over the dividing line between the lit and dark sides. It may aid in temperature regulation and the creation of more ideal living circumstances. Scientists believe T-Garden b has an atmosphere with a density between 1.3 and 1.7 times that of Earth's, which might sustain the presence of liquid water on the planet's surface. Hycean planet. Hycean planets are distinguished by their hot, ocean-covered surfaces and hydrogen-rich atmospheres. The quantity of hydrogen can cause high atmospheric pressure on Hycean planets, causing their atmospheres to differ significantly from Earth's. Hycean planets with dark sides may be livable only on their night sides, where heat from the star is trapped, while their day sides may be exceedingly hot. Cold, icy Hycean worlds receive little radiation from their stars, but their surface pressure is comparable to that of the deep ocean on Earth, suggesting that they could support life. Because of their larger size and higher temperatures, Hycean planets have a better chance of identifying biomarkers in their atmospheres, which could indicate potential life. Superhabitable worlds. Superhabitable worlds are hypothetical planets that potentially have even better conditions for life than Earth. The ideal age for a super-livable world is predicted to be between 5 and 8 billion years, allowing enough time for sophisticated life forms to originate and evolve. These planets would be slightly larger than Earth, providing more land for life to survive on. Superhabitable worlds would have a slightly higher mean surface temperature, roughly 5 degrees Celsius higher than Earth. The longer lifespans of the stars orbiting these planets would allow for lengthy periods of stability and the potential evolution of life. Finally, NASA's groundbreaking discovery offers a fascinating insight into the amazing diversity of the universe and confirms the notion that we are not alone in the universe. It reawakens our sense of wonder and stretches the frontiers of our imagination, allowing us to consider the potential of life thriving beyond Earth and to embrace the limitless possibilities that await us on our cosmic adventure. Thanks for watching. Please hit that like button and subscribe to our channel. If you want to watch more videos like this,